Hey you guys, this is Mr. Sal. Thanks for watching. This is a lesson about alternate exterior angles, alternate interior angles, corresponding angles, straight angles, vertical angles, and straight angles. So thanks for watching. Go ahead and comment below, hit the like button, and subscribe. Good luck. It's the start of Unit 13, Special Angles Formed by Transversals. Now usually the two lines that a transversal intersects are parallel, but not in the case for today, which is okay. But we'll look at some different relationships that the angles are forming from the transversal. So, in the picture below, line L and line M are cut by a transversal line called T, which is right here. But then number 2, define transversal in your own words. A transversal is a line that intersects two or more other lines at the same point. Some people say that it would cut two or more other lines, just again, not at the same point. So T right here in this diagram is a transversal. And then the second part says to draw another transversal for the two lines above and label it line R. Now when we label lines like these, we usually use lowercase letters. So there's a couple ways you could draw it. Well, there's several, but this would be one of them perhaps. And we'll label it line R.
Can it be like parallel with line T?
Sure. What we can't do with this line R that we just drew is make it parallel to line L or line M, because then it will never intersect one of those two. And also, I mean, if we extended these two lines, maybe they intersect somewhere over here. We couldn't make it go through the point of intersection. No, we could not do this. So this not at the same point business is kind of a big deal. So here are our two lines. Let's call them A and C. And if the transversal right here goes through that point of intersection, maybe this one is D, then D is not a transversal because it is intersecting at the point where the other two lines intersect.
But if it was anywhere else, it would?
But if it were anywhere else, it would be just fine. Okay, so if I did a different transversal like these, see it still goes through this point. So this one, E, line E is also not a transversal. So transversal is just one of the vocabulary words we're going to cover in this unit, but there are several, and while I don't think that vocabulary is, it's going to ask you what vocabulary means on the test, it will be used quite a bit on the test. So if it asks for a transversal and you didn't know what it was, then you won't be able to do the problem, okay? So something like this one. Some of the runways at a major airport are shown in the drawing below. Identify these two sets of lines to which each line is a transversal. This is the JFK Airport in Dallas. So I don't know if that's true actually, and I think JFK is in New York, but whatever. We have line A. Line A is right here. Line A, which other sets of lines is line A transversal with? Well, it appears that we have line D because it intersects it right here. Now it has that arrow, which means that it would extend or it would keep going down to line E as well. So yeah, some of you would say maybe F, and what other line?
C.
C, sure. Right? Because if it were to extend this way, then it would eventually intersect with C right here, which is okay. All right. Now, what about, could we say D and F?
Yeah.
Could we say C and E?
Yes.
Yeah, there's lots of different ways to list these. But is the line B ever is line A ever a transversal with line B?
No, because they're parallel.
That's correct. It cannot be line B. Now let's look at line B, which is this one, right here. So let's look at some pairs of lines that it is a transversal with. Yes, E and D would work. C and D would not work.
Nice, Olivia.
Why? Because it intersects it at this point right here. It's at the same point. So it would not be considered a transversal for C and D. C and E work. What else? Yeah, these, F and D would work as well. But what line is it never transversal with? A, very good. Can never be transversal with A. All right, next up is line C. Let's highlight line C right here.
D and E.
This one. Very good. D and E would work.
B and.
All right, so there's a couple more. Let's look at line E now. So line E here in gray would be a transversal for C and
D.
well, D is parallel to line E, so it couldn't be C and E.
C
A
and
D.
D.
C and B would work. Maybe C and
A.
A. Maybe C and F.
F.
Maybe F and B.
F and B.
All right. Now, something like these, okay? But again, line E here in the gray can never be a transversal for line D because they are parallel.
There's our form. Use angle names provided by your teacher to move the angle names around the picture below until you think they have found its correct location. Be ready to justify your reasoning. There will be several correct locations for each set of angle pairs, and more than one term may fit in an angle.
Thank you. So the two of the main words we're going to be looking at right now are exterior and interior. So the exterior, usually this is associated with houses, I suppose. I don't know what else, really. Like the exterior of a house is the outside, and the interior would be the inside. Yep. All right, so for this diagram that they've given us, just to indicate, the inside would be between the two lines, so the interior is kind of between these two lines, kind of like you would have with a sandwich, right? The interior is the inside of the sandwich, where the PB&J goes, where the meat and the mayo and the mustard and the lettuce and the ketchup and the peanut butter, okay? So the outside would be on the outside of the sandwich, kind of like the bread, right? All right, so this would be considered the outside, well, if I could spell it. All right, so the outside would be what you put on the outside of the sandwich, like more cheese or bread or...
Exterior, no outside?
Sure, I don't know what people do, man. It's kind of weird, right?
Put cheese on the outside?
Yeah. A cheese sandwich. Isn't that how that works?
I was talking about cheese. Can I?
Yeah, if you wanted to write exterior, that's fine. Let's do that. Then we also have the word alternating, which we need to understand. Alternating in one for another is just kind of like opposites in this case. When we alternate in numbers, we're looking at every other number. But here we're looking at alternate, in this case, ankles, which, for example, an alternate ankle in the top left, the alternate would be in the bottom right. So they're kind of just opposites that way. Yeah, and so just to relate this to the number thing, an alternating number sequence would be 1, -2, 3, -4, alternating between the signs, which are the opposites, okay, something like that. There we go, directions, color code the following sets of ankles. By coloring each set of ankle pairs the same color, find at least 2 sets of special ankles for each drawing. Alternate exterior ankle pairs. All right, so these ones need to be on the exterior, first of all, which would be the outside, right, out here. So they should be somewhere in this area. Definitely, we should not see anything on the inside or the interior in here. Now we are looking at ankles, so for example, we could identify this ankle right here. Let me make that a little bit more bigger right there. Something like these. Now, remember, this is alternate exterior, so it does have to stay on the exterior or the outside. Alternating, in this case, is the opposite. So if I'm in the top left, the opposite would be the bottom right, which is this ankle. These two are alternate exteriors. But then we could also look at these. This one is in the top right, so its alternate exterior would be the bottom left. Yeah, right? So on these, let's identify the interior as this stuff right here. So we're not looking on the inside of the sandwich, we want alternate exterior ankles. So if I was right here at the top outside left, then it would be at the bottom outside right here. And so naturally the other two will be alternate exterior ankles as well. All right, now let's look at alternate interior ankle pairs. So just before we do, we can identify that we are not going to be on the exterior out here, or on this one we will not be on the exterior out here. It should just be inside the sandwich because it's interior. So let's identify alternate. It's got to be on the inside. All right, so let's just look at one of these interior ankles. This one is interior, but we want something that's alternate interior with it.
So it'd be on the other side.
So it'd be on the other side, bottom right. This one's top left, bottom right. Alternate interior ankles. Then we got this one right here, which would be in the top right, so it's alternate, would be in the bottom left, but interior right here. Alright, good luck.
Okay, so then this is an angle right here. And so the alternate one would be over here.
Correct.
And then this is an angle. Then the alternate one would be over here.
Correct. Excellent word.
Wait, so alternate.
All right, next up are corresponding ankle pairs. Corresponding means that they're in the same position but on different or at different intersections. So we're not looking at interior or exterior anymore. We're just looking at corresponding. So to start us off, let's just start with this ankle. Let's identify the two intersections, by the way. We've got this one and then this one. So the red dot that we have right now at that intersection in green is in the top left. So we go to the other intersection and its corresponding ankle would be in the top left. Same position, different intersection. Alright, so let's look at a different one. Something like this one right here. This one at that intersection in green is in the top right. So at the other intersection in green, it would also be at the top right. These are corresponding ankles. Same with this one and this one right here. Yeah, then we got this one and this one. Corresponding angles, all, well, with corresponding colors. It's kind of nice. All right, good luck.
Thank you. Okay, so this is the exterior, right? These are, why is it so big? These are the interiors, okay? So, one can go right, let's do purple. One can go right, why isn't it going? Oh, it's good now. There. Wait, I did that wrong. Where's the eraser? Oh, I found it. Wow, guys, I'm really good at this. Okay. That's, what the?
That's the marker.
We could just, no, stop. Now I need to erase this. Okay. then you could do blue. Okay. But then you could do more over here. So let's get some green. Orange. Done.
Colorful, excellent work.
Here you go.
Thank you. Next up are the vertical ankles. Vertical ankles are literally through the vertice. Vertical and vertice. Vertice is an intersection. They're angles through the vertice. All right, vertical ankles are angles through the vertices or the intersection. And what's fortunate about vertical ankles is they are always congruent. Meaning if one vertical ankle is 70 degrees, then the other vertical ankle would be also 70 degree, which is extremely convenient. So, again, a vertice is also an intersection, which we did in green before, so hopefully this will help. And we can identify these. For example, just starting with any one of the ankles, like this one right here. We go through the vertice to the other side, and this is also vertical with it. Now again, these ankles would be the same size, so we could use the ankle marks like we've done before, like these. Now we can identify this ankle pair. This ankle would be vertical through this one to these. I did the lines only because that is how we show that they are congruent with the same markings. But that is not all. We also have these, 1, 2, 3. And it would be through the vertice to these, 1, 2, 3 marks, right here. And then finally we got at these one right here. Just doing a different marking to show that they are congruent. So we should be able to do the same thing on this one right here. If I start with, I don't know, this ankle, it would be congruent to these. This ankle would be congruent to these. Then we got this one right here, congruent and vertical to this one. And then we also got this one, vertical and congruent to these. And those would be pairs of vertical ankles. Next up, straight ankle pairs. Straight ankles, when we combine them, will make, as it turns out, a straight line. Or some people prefer to look at it as 180 degrees. It is the same thing. Usually they intersect in the middle of the line, the two ankles. So, for example, what you'll find is you got an ankle like this one. And there's our ankle. And then we combine it with this one to form, if we were to push them together, these would form a straight ankle or a straight line if we were just to get rid of this garbage right here. Now we got a straight line. And that would give us 180 degrees of ankle. So pairs of ankles that make a straight line or 180 degrees. These are also known as supplementary ankles. And find ourselves some straight ankle pairs, such as, let's start with, doesn't really matter, this one right here. This one is a straight ankle pair with this one, but also with this one right here. So it doesn't matter if you use this one, or maybe use these two only. So these two make a straight ankle with this line right here. These two make a straight ankle with this line right here. Nope. So the other set would be maybe this one's right here. Alright, next up, let's identify this ankle right here. It would make a straight line with this ankle. And then finally, we have this one. which is, yes, it would make a straight ankle radical, but also radical as well. Let's do it on this one. It's extremely difficult now. We got this one and this one, or this one and this one, or this one and this one, or this one and these, or these. I ran out of colors. Refer to the figure below. Identify the following pairs of ankles as alternate exterior ankles, alternate interior ankles, corresponding ankles, vertical ankles, or straight ankles. So let's start first by just identifying where they are. And once we do that, we should just ignore all the other lines that are not intersecting at these intersections. So for example, 1 is radical, 8 radical, which means that in a way we could just kind of ignore all this other stuff. Radical. Okay. So we can see, hopefully, let me put a little bit more on that. Something like this. So hopefully this makes a little bit more sense once we ignore those. Yes, these ones are alternate exteriors. Identify where they are. I'm looking at 12 and 11. And these two appear that they make a straight line, so these would be straight ankles. Next up is 13 and 21. Now this one kind of confuses a lot of people. So just so we can understand this, let's just ignore these other parts. Like this stuff right here. Okay? And even this stuff and this stuff. Okay? So that may help us to see what their relationship is. These two, if we look at just these two intersections, they are corresponding. Very good. Next up is 14 and 15, so 14 here, 15 there. These two are very good. Vertical. All right, next up, let's see, what do we got up in here? 7 and 14, 7 is radical, 14 radical. So again, you got to be able to ignore the rest of those intersections and where the lines are. But these two would be alternating interior. Yeah, so maybe this will help, right? If we get rid of this other stuff.
It looks like one of those sandwiches that has like the little toothpick sticking out.
Right? Now we can see that they would be interior right there. Hopefully. All right, next up, 9er and 20 radical. These are alternate exterior. Again, you've got to be able to ignore all that other stuff, right? So let's look at that. Something like this shows that they are now on the exterior and they are alternating. All right, next up, 5 and 7 radical. These two are adjacent to each other, and we know if we combine them, we would get a straight line. So they are straight ankles. Let's look at the next set. We got 22 and 23 radical. So these two are hold on. Yep, we got 1 and 5er. These are corresponding. Yep, we look at the same the two intersections, and they're both in the same position for each intersection. So they are corresponding. All right, 21 and 18, 21 and 8 rather. So we got 21 and 8. So we're going to ignore that transversal line R. Just ignore it and the intersection with ankles 13, 14, 15, and 16. Ignore that, which means that would put 8 and 21 on the interior, and they are alternating as well.